you. So today we're on the hunt for a fugitive gas. And I guess this is what happens when you put a dad on the stage. You're sure to get some dad jokes along the way. So forgive me for this one, but follow along. So methane, our fugitive, is the world's second most abundant human-caused greenhouse gas. It has 25 times more warming potential than carbon dioxide in the atmosphere over 20 years, and it's responsible for 30% of the warming we've experienced since pre-industrial times. Now, the rewards for capturing or reducing methane emissions are enormous. You see, methane, while it's potent greenhouse gas, also has a short half-life. This means it degrades quickly in the atmosphere. So we're likely to see a quick benefit in terms of near-term temperature rise if we reduce methane emissions. Studies estimate that we can avoid a 0.3 degrees C rise in temperatures by 2050 if we take ambitious actions to reduce methane. Now, don't let that 0.3 degrees C number fool you. This actually is a big deal. It represents about 20% of the overall 1.5 degrees C limit or goal that we set for ourselves at the Paris Climate Accords. Now, here's the challenge. Fugitive methane or methane emissions can come from diffuse sources. This could be blasts at an open pit metallurgical coal mine, anaerobic decay in landfills, burps in cows, or leaky oil and gas pipelines. And so what do? Rather than measuring precisely where everything's taking place, we rely on models. And we all know models have their limits. In this case, modeled methane emissions often come with a really large uncertainty or a range of where we think those emissions are taking place. This can lead to underreporting or overreporting. And something that's maybe not talked about as much that we think about a lot is often these estimates aren't that actionable. You may get one estimate for a whole landfill for the whole year, for example. Something that coarse is hard to act on. And that's where my company comes into play. I'm part of BlueSky Resources. We're a company in which Stantec has taken an equity stake and invested significant technical resources. We've built a technology called AirLogic that we can use to better measure and model methane and greenhouse gas emissions. And I want to take you through how that technology works. We're going to start with that coarse modeled estimate of emissions that I mentioned earlier. The one you can see on the left here with a really large uncertainty. And we're going to use measurements in our platform, AirLogic, to bring it all together and refine this estimate into something more actionable. We start by collaborating with our customers to establish a multi-sensor monitoring strategy. Customers may have existing sensors in place. In that case, we help them bring the data together into one platform. But we also make suggestions for other sensors that would be beneficial to monitoring their facilities. This could include ground sensors, handheld devices, drones, aircraft, satellites as well. We collect all these measurements into AirLogic, and as we go through here, I want you to notice how we use these measurements to do two things. Number one, we're going to use them to reduce the range and the estimated emissions, and you can see that happening on the left. The other thing these measurements are going to do are help us spatially and temporally place the emissions. So you can see that on the map. So these measurements we collect may include measurements from ground sensors, drones, satellites and aircraft, like I mentioned. And the result is something like this, bringing all this together. What you're seeing here is a refined emissions estimate where we've taken all these measurements. We've worked really closely with our partners at Stantec, and I specifically need to call out the work of Reed Person here. And we've developed something which, from our perspective, is really innovative. So this is an emissions estimate where you see on the left a much more precise estimate of the emissions taking place at this site, which in this case is a landfill. And you also see a more accurate picture of where these emissions are happening spatially and temporally over time. We don't stop there. Our next step is to work closely with our customers to aggregate their operational activity data and bring that into our system as well. So this may include measurements from a landfill of how much trash they've collected month by month, or data on where blasting took place at a open pit coal mine, for example. We bring it all into our technology, our UI, called Rosetta. And Rosetta makes it very easy to compare both the emissions data and the operational data together all in one place. The result is this. We've taken those coarse emissions estimates and we've turned them into an updated version of the estimate, which now is more actionable. From these updated estimates, we can derive very specific conclusions about when and where emissions are occurring and which operational activities are drivers of those emissions. See if it'll go. I want to point out that we do this not just for one site. We do this scalably across our customers' portfolio of sites. In this case, it could be tens or hundreds of sites. And we do this to give our customers an accurate picture of how they're tracking towards their overall climate goals. Recently, we've done work on knowledge transfer using some of the multispectral imagery that Martha's mentioned to increase our capability around methane detection. And we've worked closely with our customers in hackathons to leverage computer vision to identify assets, and then also, like I mentioned, more accurately identify where emissions are coming from. So let's bring all this together. One last dad joke, I guess, right? This technology gives us the tools we need to capture methane and to do it at scale. I think it's a big reason why we've chosen to work at a place like BlueSky or Stantec. We get to use this technology with our customers who are on the front lines of the fight to reduce emissions. And what we're finding is our customers, using these more actionable emissions profiles in oil and gas, mining, and waste management, they're able to use it to chart a profitable path to adapting operational activities in a way that reduces their emissions. The point being, this technology has a real chance of moving the needle on climate change. And as a dad, that's one of the reasons why I'm here. Thank you all.